A black hole is an object whose gravitational field is so strong that even light cannot escape from it. To what approximate radius would Earth of mass 5.89 into 10 raised to minus 24 kilogram has to be compressed to be a black hole? So the concept over here is that the escape velocity should be equal to the velocity of light, and we know that the velocity of light is 3 into 10 raised to 8 meter per second. So if escape velocity is equal to velocity of light, then even light cannot escape from it, so we call it as nothing but a black hole. Now if escape velocity of a planet, we know that it is escape velocity of an object from the surface of planet is under root of 2gm divided by r. So according to this question, this should be equal to 3 into 10 raised to 8 meter per second. Then for that purpose, we need to find out what about the value of its radius. So we can try to this, if you are squaring on both the side, we can take it as 2 into g into m into r is equal to velocity of light. I'm just representing it as c, so we can try this is equal to c square, and rm is to find out the value of this r, so we can write r is equal to 2gm divided by c square. So we can put these values, so we can write r is equal to 2 into g, we know that 6.67 into 10 raised to minus 11. The mass of earth, it is given that nothing but 5.98 into 10 raised to 24 divided by c square. C square we can take it as nothing but velocity of light, its square, that is 9 into 10 raised to 16. So we can find out what about the value of r over here, which is around 8.86 into 10 raised to minus 3. Or if you are approximating, this is like 10, so 10 into 10 raised to minus 3, or we can take it as it is around 10 raised to minus 2 meter.